Good morning. So, today we will continue with our discussion on energy storage and devices. So, in the last lecture, I discussed some problems on various energy storage and devices covering battery, lithium ion battery, supercapacitor, etc. And today we will see some questions related to fuel cell, and then we will review the entire topic in various frequently asked questions. So, the first question is write configuration and working principle of fuel cell. So, as we discussed, the fuel cell is actually a device which works on the principle of generation of electricity from a fuel like hydrogen, okay, and which gives water as an output along with the electricity. So, if we recollect what we discussed about the configuration of a fuel cell, that in fuel cell we have an anode and cathode, and then we have a membrane here, okay. So, hydrogen goes in this anode and there is oxygen in, there is hydrogen in, all right. So, it produces say H plus ion, hydrogen gets converted to H plus ion, which goes to cathode, okay, react with oxygen and give water, and electron force in the outer circuit, okay, which combines with H plus there, and there is a kind of load here which produces electricity. Okay, so it is a very clean energy generation process, electrical energy generation process, because it just gets converted from H2 to H2O, and if we have provided we have a green supply of hydrogen, which is a fuel here, then the entire process is a green process. Coming to next question, what are the energy conversion steps in heat engine and fuel cell when the required output is electrical energy? Which one is better? So, if you remember that we discussed different energy generating devices which can compete with fuel cell like heat engine, battery, etc., and we made a comparison, because we can have an output energy like electrical energy or output energy like mechanical energy. So, when we consider electrical energy as output energy and look at fuel cell, then it first becomes chemical energy, we are just looking at energy conversion paths, and then it becomes an electrical energy. Okay. But in case of heat engine, it gets converted into chemical energy, and then thermal energy, mechanical energy, then electrical energy. So, if we look at the conversion paths, it is important to understand that which one has a has minimum energy conversion paths when it goes to an output as electrical energy, and it is clear that fuel cell path is much lesser as compared to heat engine. So, therefore, in that sense fuel cell works or fuel cell is a better energy converter in terms of the steps which it takes much less as compared to heat engine, and therefore, we can say the fuel cell is better. Next question: what are three major applications of a fuel cell? So, if you remember that we discussed several applications of fuel cell, highlighting applications of different fuel cells in different the appliances and other technology. But now what we will see that if we broadly classify the application of fuel cell, how can we classify this fuel cell? So, we can make the three classification. One is say portable application. So, when we talk about portable application of a fuel cell, we find the application in portable power generators, in consumer electronics, portable military equipment, battery chargers, miniature toys, kits and gadgets. So, these are all portable applications. So, they are you can say small scale application of fuel cell. Coming to the transport application, which is the second application of a fuel cell. There are several auxiliary power units where fuel cells are used: light traction vehicles, light fuel cell electric vehicles, heavy fuel cell electric vehicles, marine propulsion and aerial propulsion. So, we can see that as far as the transport application is concerned, fuel cell covers lot of transportation facility or transportation devices or transportation equipment were used in various application. Okay. Now, if we come to the third application, that is stationary applications, it can be used as distributed power generators, and we have also mentioned that the fuel cell can be used in a power generation process in you can say in a small area covering a human habitat. Okay. And suppose we are considering this power generation process of a small colony, then fuel cell can be used as a power generator, efficient power generation process. It combines heat and power, combining cooling, heat and power as backup power supply and remote area power supply. Okay. So, these three major applications of fuel cell along with all these applications which fall under these three major category, it clearly shows that the fuel cell has a versatile application area in day to day life or in the technology. Make a comparison between different fuel cells in terms of their output power and efficiency. So, if you remember that we talked and also I have shown you different tables highlighting the different fuel cell, their application process, their working principle, and then which one is better and at what temperature range, this was discussed. So, here let us see in a graphical sketch which fuel cell is used at what temperature and what is the efficiency and output power of different fuel cell. So, if you look at this graph, here actually different type of fuel cells which are mentioned, and here the output power is mentioned. So, if we first look at PEMFC, then it's the red one actually indicates maximum output, and this blue one with the dot, it indicates the operating temperature. Okay. So, you can see that the operating temperature for PEMFC is relatively less, the 250 degree, and this is the output power which is less than 500 kilowatt. Okay. So, now if we look at AFC, its output power is even less. All right. Now, looking at PAFC, it works at a higher temperature and output power is less than other other fuel cells like MCFC and SOFC. Coming to MCFC, okay, it works at slightly higher temperature as compared to other fuel cells, and its output power is also same as PAFC. Now, if we look at SOFC, it works with maximum operating temperature with output power which is maximum for all these fuel cells. Okay. So, it depends at what operating temperature we are considering and which fuel cell gives us better output power. However, we have to remember that for application which one is better for which application, and that I discussed in detail that which fuel cell is more suitable for what application. Now, coming to efficiency, this again it shows x axis shows various fuel cell and y axis we have efficiency, and the blue one indicates the electrical efficiency and the red one indicates combined heat and power. So, if you look at PEMFC, then you can see that efficiency is around 60%. Okay. AFC, the efficiency is almost same as PEMFC. When we consider PAFC, electrical efficiency is slightly lower as compared to other two. MCFC is slightly higher as compared to PAFC, okay, and SOFC is slightly lower. Okay, but if we look at this combined heat and power, then SOFC is the maximum, AFC is the minimum, and we can say PAFC is the intermediate. All right. So, these two things are very clearly indicated in this graphical sketch. We go to the next question. Make a schematic on transport application of a fuel cell. So, we discussed about the transport application of a fuel cell, and if we look at it, what typically a fuel cell car we can say it consists of. So, this is a fuel cell car where we have here the fuel cell stacks, and what we need in the fuel cell is the fuel which is hydrogen. So, we have hydrogen tanks here, and then you can see ultra capacitors. So, ultra capacitors are basically the devices which we discussed in the previous tutorial session also. They actually delivers power in a burst. Okay. So, whenever there is a need for acceleration, okay, or some kind of braking, that ultra capacitors are useful for that, and this is the electric motor which is is a General Electric motor which is used for all car, and this is a fuel cell system radiator, a power control output and powertrain radiator. So, these are the major components of a fuel cell car. So, schematically if we look at, this is a fuel cell stack, okay. This is a chamber for humidification, and we have an air supply through this, and this is actually the fuel supply which is high pressure hydrogen tanks which we have shown in the car here. There is a cooling system which is connected with the fuel cell stack, which is basically giving the energy, and this is drive motor, and ultra capacitors are here, as we have mentioned that ultra capacitor basically delivers power in a very short time for some typical application like acceleration, braking, etc. So, this is the schematic of a fuel cell car, and now we will go to and compare different fuel cell in terms of their operational temperature and the materials used. So, the question is, make a comparison between different fuel cells in terms of operational temperature and different materials used. So, we have discussed in detail that what are the materials used in fuel cell and what operating temperature. Let us look at again in a tabular form. So, let us start with PEM, that is polymer electrolyte membrane. Its operating temperature is lower, as I mentioned in the previous question also, 70 to 110 degree centigrade. The fuel used is H2, hydrogen and CH3OH. Electrolyte is basically a sulfonated polymer, okay, or Nafion, and the mobile ion is H plus. Okay. Now, come to alkaline fuel cell AFC. Operating temperature is slightly higher, that is 100 to 250 degree centigrade. Its fuel is H2, and the electrolyte used is aqueous KOH, and the mobile ion is OH minus. The next one, phosphoric acid fuel cell, its operating temperature is 150 to 250 degree centigrade. Fuel is hydrogen, electrolyte is H3PO4 because it is phosphoric acid fuel cell, and its mobile ion is H plus. Come to MCFC, that is molten carbonate fuel cell. Its operating temperature is higher, as we have seen in the previous graphical sketch also, 500 to 700 degree centigrade. Hydrocarbon is a fuel, electrolyte is sodium or potassium carbonate, and carbonate ion is the mobile ion. Now, the last one, SOFC, solid oxide fuel cell, it is a solid state fuel cell with operating temperature 700 to 1000 degree centigrade. Hydrocarbon fuel is used, okay. Yttrium doped zirconium oxide is the main electrolyte, which is a solid state electrolyte, and O2 minus is the mobile ion. Now, we come to next question. Some nanomaterial based electrocatalyst shows high durability of fuel cell. Why? So, if you remember that we discussed different nanomaterials in fuel cell, okay, and nanostructured materials, combination of nanomaterial or composite nanomaterials, graphene, etc., and why it is important to go for nanomaterial when we talk for durability. So, there are three major or important points when we use nanomaterial for fuel cell. One is increased surface area. So, we know that surface to volume ratio increases in case of a nanomaterial, nanostructured material, okay, and that eventually increase the surface area and also the electrolytic capability, okay, because if we have a larger surface area, it is this capability is more, okay. And then enhanced dispersion of the ion inside the nanomaterial, because they have the very high conductivity, okay. And suppose you consider graphene, or if we consider say carbon nanotube based nanostructure, or any other nanostructure like we discussed about nanoflower, nanocomposite, etc. So, we have enhanced dispersion, and another very important point is improved stability. Okay. This has been observed that the nanostructured materials, when they are used as electrocatalyst, it gives much better stability. So, in terms of overall durability, nanostructured material is better. Now, we come to one specific application, that is graphene. So, the question is 2D nanomaterial like graphene and graphene based compounds play an important role as electrode in fuel cell. What are the importance? So, if you remember that graphene is, as we mentioned, that it is used here, or graphene based material if we consider. So, what are the key points why graphene or graphene based materials are used? It is having good chemical stability, exceptional electrochemical properties, excellent mechanical strength, and that is what we discussed about the stability, high electrical conductivity and large surface area. Okay. So, these are the broad the properties of graphene, which actually makes it very important material for as an electrode in fuel cell. So, now if we look at few graphene and few of its compound. So, as I mentioned that when we consider graphene, it is having large surface area, high charge mobility, high chemical stability, strong mechanical strength, etc. Okay. So, now if we look at another compound like graphene oxide, it is having strong hydrophilicity, high proton conductivity, moderate electrical conductivity and tunable electrochemical behavior. Now, come to heterojunction doped graphene, which have been reported in the literature. It is having property like tunable charge and spin, density distribution, abundant active area, high electrolytic capacity, fast heterogeneous electron transfer rate. Okay. So, these are some important properties of graphene and graphene based compounds, which make it a very strong potential candidate for electrode in the fuel cell. Now, we have discussed on various morphologies of nanostructured morphologies, which are used in these electrocatalyst, electrode, etc. So, one interesting morphology what we have seen is platinum nanoflower, and which has been observed that platinum nanoflower works even better than the commercial platinum carbon. Okay. So, the question is platinum nanoflower, the morphology which is shown below, shows better performance over conventional platinum carbon. Why? Again we come back to the same points, that is when we go for nanostructured material and it is very nicely designed nanoflower of platinum. So, we have a highly enhanced surface area, okay, as compared to the bulk platinum carbon, and then it also shows enhanced oxygen reduction reaction, ORR reaction. It is having mass transport, because I told you that because of the nanostructure the transport is always better, and also as I explained, it is having better durability and stability. So, so it makes the platinum nanoflower a better candidate as compared to conventional platinum carbon. Now, we also discussed about some nanocomposite. So, let us again look at that what are the nanocomposite these are used in the fuel cell. So, the question is list down some nanocomposite and their specific application in various fuel cell. So, let us look at say 1D on 1D kind of nanocomposite. So, in this case we look at one particular example where platinum nanorod and nitrogen doped carbon nanotube. Generally it is been reported in PEMFC. So, it again gives improved durability, better stability of nanorin, and the stability it gains from the nitrogen doped carbon nanotube. So, this is a good support for this material. And then another material is MoO3 nanorods with Fe2 MO4O3. This is used in SOFC, solid oxide fuel cell, and it is having excellent long term stability and high temperature. And then one is platinum nanoflower, which we have discussed, and now if we introduce porosilicon as a nanocomposite, which is used in DMFC, which people have demonstrated, it exhibit excellent catalytic activity as we have discussed in the previous question. So, it clearly shows that the different nanomorphology or nanostructured material had lot of potential when the application of fuel cell is concerned. So, what are the major advantages of a fuel cell and what are the disadvantages? So, if we look at the major advantages of fuel cell, as I mentioned, if we note down the major advantages, or number one is it is a very clean source of energy. It is clear that it is clean source because we have hydrogen as a fuel and there is nothing which can contaminate it. There is no other materials or anything which can create any toxicity or anything. So, it is a clean source of energy, and number two is that its versatile application, capability of versatile application. So, we have discussed that it has the capability to use in the portable devices, transportation, as well as very some stationary the engines or the power sources. So, this actually makes the fuel cell very advantageous. Number 3, it is higher stability, and 4 is working at different temperature range. So, we have seen that what are the temperature range of fuel cell covers. So, you can see it from 700 to almost 1000 degree centigrade, the range that it can cover, and it also gives a different output power, and depending upon the application we can depending upon different application we can decide that what is the the output power required and which fuel cell we need to use. So, now if we look at disadvantages, Okay, so the major disadvantage with fuel cell is its hydrogen as a fuel. Okay. So, this is a very important thing, because if we have a hydrogen generation process which itself is not a green hydrogen generation process, then hydrogen generation or from the generation process of hydrogen, there are some kind of the environment pollution can arise. So, now let us review the chapter with different frequently asked questions. So, the first question is compare fuel cell and supercapacitor in terms of energy and power density. Okay, so, if we look at the supercapacitor and fuel cell, okay, the energy density is higher for fuel cell. Energy density is higher for fuel cell, and power density is higher for supercapacitor. The reason why energy density is higher for fuel cell is that it is mostly a chemical energy generation process, and therefore, more energy can be stored in the fuel cell. And the power density is higher for supercapacitor, because what we have seen that it is a process of electrical energy storage, okay, and it can deliver powers very fast, and therefore, its power density is higher as compared to fuel cell. What do you mean by primary and secondary batteries? Give examples. So, we always use batteries, some batteries are primary and some batteries are secondary. So, when we call a battery a primary battery, when we cannot recharge it. Okay. So, battery is a kind of one time use is primary battery, okay, like alkaline batteries. But when we talk about a secondary battery, it gives it that we can multiple time we can charge this or charge the battery, or what we call it's rechargeable, like nickel cadmium cell. Okay. And that we always use the rechargeable batteries in various in our home appliances. So, we are well aware about the secondary batteries or the application of secondary batteries. What is the role of dielectric capacitor? Very fundamental question. So, we know that actually a capacitor, it consists of two plates, and in between there is a dielectric. What is the role of dielectric? The role of dielectric is that it can hold charges. Okay. So, entire energy density which we get in the in the capacitor is basically it depends on the capacitance of that dielectric material. Okay. So, it is to be designed in this way, all right, and also it sort of makes a separation between the electrodes, because when we make a capacitor, the two plates are actually very close when we consider a small capacitor, and therefore, there is a chance for the shorting or kind of the two electrodes may touch each other. So, you have a dielectric in between, it actually separates the two electrodes, all right. What is the difference between capacitor and supercapacitor? So, what we have discussed, this is a capacitor, as just now I discussed that in the capacitor the typical configuration is that there are two plates, in between there is a dielectric, okay, and the charges are polarized in the dielectric, okay, it holds energy for the entire capacitor, okay, or the electrical energy which is being generated in a capacitor is directly proportional to the capacitance of the capacitor. But when we talk about supercapacitor, supercapacitor actually works on the principle of electrical layered, double electric layer to begin with, which is EDLC. Apart from that also we have pseudocapacitor which works on oxidation reduction reaction. But if we just compare it with EDLC, that is electric double layer capacitor, or the first supercapacitor that people have invented, this actually works in the principle of double layer. So, it forms a double layer of charges across the or near this electrode or electrode electrolyte interface, and it holds higher energy as compared to capacitor. So, if we look at the energy density, okay, so in terms of energy density, supercapacitor is higher, and in terms of power density, capacitors are higher because capacitor delivers the power a little faster. All right. So, now we go to the next question, which one is better in terms of specific power density and cycle life? Let us say battery and supercapacitor, and why? So, again we try to recollect the Ragonnet plot which we have shown in terms of the energy density and power density of different storage devices. Again battery, which is a chemical energy storage device, has higher energy density. So, lead acid battery has higher energy density, okay, but the supercapacitor has higher power density. So, the reason is that it delivers power faster because the lead acid battery works on the principle of chemical energy storage and supercapacitor works on the principle of electrical energy storage, and therefore, it can deliver power faster to the devices or to the load which is connected across it. So, there is a basic difference between these two in terms of operation and also in terms of cycle life. Supercapacitor is better as compared to lead acid battery that we have seen. What is a hybrid capacitor? So, we have seen there are different capacitor. One is electrical double layer capacitor, which works on the principle of double layer formation across electrode and electrolyte interface, and pseudocapacitor, which works on the principle of oxidation reduction reaction. Okay. And the hybrid capacitor is a capacitor which one can design in a way that combining both supercapacitor of EDLC type and pseudocapacitor type. Okay. So, one electrode one can design as EDLC type, another electrode one can design as pseudocapacitor type or make a hybrid kind of supercapacitor. So, sometimes people call it that it is a hybrid in such a way that it falls in the range of supercapacitor and battery. Okay. So, there are different hybrid capacitors which we have discussed in the previous tutorial session. What are the advantages of using carbon nanotube as an electrode material of EDLC? Okay. So, carbon nanotube offers lot of advantages. The first one is higher surface area, high conductivity, that is higher conductivity of the charges because it is CNT, and high stability. Okay. So, there is a reason why CNT is used as an electrode of EDLC. why RuO2 is used as an electrode material of pseudocapacitor. So, we discussed that RuO2 is a ruthenium oxide is a very standard material for pseudocapacitor, because RuO2 has a very important property. Ruthenium can exist in different oxidation state, that is what we have mentioned. Okay. So, it can facilitate ORR or oxygen evolution reaction, okay, and also it can provide a better stability or higher stability as compared to other electrode material which are used in pseudocapacitor. And question 9, what are the advantage of lithium ion battery over the rechargeable batteries? Okay. Again, lithium ion battery is a battery which is designed in a very specific manner, as we have discussed, as compared to conventional rechargeable batteries, because in lithium ion battery you have actually movement of lithium, intercalation of lithium in different electrodes, movement of lithium, okay, and it is having higher energy density, as well as it can also transfer its or deliver the energy to the load more efficiently as compared to other normal rechargeable batteries that we have in the market. Specific energy of a lithium ion battery is much higher as compared to EDLC. Why? So, this is again the same point, because lithium ion battery is worked on the principle of the chemical energy storage in terms of the lithium ion movement from one electrode to another electrode, all right, and then it can store more energy by this process. Whereas the EDLC is based on the electrical double layer formation across electrode and electrolyte interface, and as it is an electrical process, it is always less specific energy density as compared to any storage device which is based on chemical process. So, if we just look at the entire tutorial discussion, that what we have discussed in detail, all these energy storage devices, what are the the typical issues of the energy storage devices, okay, in terms of say capacitor, supercapacitor, battery, fuel cell, lithium ion battery, etc. And we have seen what are the typical questions that one can expect in a fuel cell, and we have also reviewed the entire chapter with a set of frequently asked questions. Okay. Thank you.